name is Jordan Van Deen, and welcome to our first AMA session of the new year. We've had above average interest in this AMA session for good reason. CO2 emissions and ways to address them seem to be in the headlines daily. It's very timely that we're having this talk because just yesterday, Justin Trudeau announced a cap on emissions for the oil and gas industry in Canada at the COP26 in Scotland. And while we don't know the details of this pledge as of yet, there are a lot of innovators who are already ahead of the curve working on ways to mitigate the release of CO2 in the atmosphere. One such company is Entropy Incorporated, which is designing and soon to be piloting modular carbon capture storage technologies. But before we get into that discussion, I just have a couple bookkeeping items. Firstly, I want to thank everyone for joining up to join our discussion tonight. I was blown away when I saw all the email handles from universities literally all across Canada, from BC to Nova Scotia, as well as companies even outside the oil and gas industry. If it wasn't for you guys joining us, it would just be me chatting with our guests, which is great for me, but pretty terrible for them. In any case, we really hope that you enjoy the hour that we have ahead of us. Alongside me is my producer, Jeff Calvert. Say hi, Jeff.
Hello.
He'll be fielding your questions, and so you might be asking yourself, how will this work? Well, as an AMA session, short for Ask Me Anything, everyone who's joined us today has the ability to ask questions of our two guests, Matt and James. And what we want you guys to do is drive the conversation. This hour is for you guys. Ask anything you want about CCUS, about Entropy, even geophysics, as Matt is a practicing geophysicist, anything that comes to mind. And there are multiple ways to do this. One is to raise your hand. You'll see at the bottom of your screen, there's a way to raise your hand to let us know you have a question. And depending on how this has been set up, hopefully it allows you to use your camera and microphone if you're comfortable doing so. But we'll have to see if those settings have been enabled. If not, you can use the chat function. Jeff will be monitoring that regularly throughout the talk. And you can even just send a message directly to him, and he's going to make sure everything is asked in the proper order. And so with that out of the way, I'd like to formally introduce our two guests. I actually ran into our first guest a couple of months ago at an event. And before I can even finish explaining what an AMA session is, he already volunteered to join and help us for his first session. That's just the kind of guy that he is. His name is Matt Ng. Hey, Matt.
Hey, thanks for having me.
Our pleasure. Our other guest tonight, he was actually recruited by another member of the CSEG Mentorship Committee. Similarly to Matt, he joined up with no coercion whatsoever. And at the same time, I had no idea that both would be joining us. So when I heard, it was sort of serendipitous to have both of them on at the same time to discuss what they're doing over at Entropy. So without any further ado, I'd like to formally introduce James Martin.
Thank you. Pleasure to be here.
Hey, James. Yeah, good to have you with us. And James, since I just introduced you, maybe you can give us a bit of a background, sort of some of the things that you worked on, your previous histories, and sort of how you ended up at Entropy.
Yeah, it's been a while here. I'm an Ontario boy, grew up in Eastern Ontario, and had a roundabout way of coming to the oil patch. When I was young, I certainly didn't know that we even had an oil patch in Canada. And I just became a mechanical engineer because I like motorcycles, essentially, as most kids, do. And then I went through university and was a little bit disillusioned. I figured, no, it's not for me. And then I did a whole raft of things between university and landing my first real long-term job, which was in the Army. Essentially, that's what got me on track. So I joined the Army just so I could move to BC, essentially from Ontario, because I like the mountains. And spent some time in the Army and then moved back. The Army actually moved me back to Ontario, and my wife was none too happy about that. And so I tried to get back to BC, and I sent my resume all over BC and didn't get one call back. One happened to go to a company in Alberta, and they're the only ones who called me back. And so that's how I wound up in Alberta working in the patch. That was in 1998. And then since then, that was a service company. And so I soon realized that I wanted to be on the producer side. I got to Calgary and a producer, basically in the vacuum that occurred when Husky bought Renaissance and all the Renaissance guys cleared out. And I got sucked into that vacuum. That was 2001 when I got to Calgary. Since then, I've been to many, many different companies, but more recently, I would say, so starting in 2010, I think it was, I got to a company called Painted Pony, and Matt knows it well. And so anyway, I was working for and with individuals that did a succession of companies. I got there because I had worked previously with our chief geoscientist here at Advantage, Darren Tisdale. We're working at Trident, and then he went to Painted Pony, and I said, "Oh, how's it over there?" He said, "It's great, so come on over." So then I started working with him, and have been working with him ever since, essentially, sort of through a series of companies. We were at Painted Pony, we went to Modern Resources, and then we went to Advantage. And the president of Advantage here was one of the founders of Modern Resources. At Modern Resources, I was involved with methane abatement. So we started to produce or equip our well sites with electric valve actuation, just trying to get rid of all the pneumatics, because we could see, with the new Directive 60 and everything, that the writing was on the wall. And so we got heavily involved in that. And then when Mike came over to Advantage here, I came over basically a few years later to work for him here. And he was always talking about doing something like what we had done with the mule sites. The mule sites were for modern ultra low emissions. So he wanted to do something on the emission side, and in the new energy transition side. And so he was looking to me to drum up some ideas. And I'm like, man, you got what I got. I gave it all at the last place, so I don't know what to do. At the same time, we had worked with a ABC, that's an EPCM here in town, a very good one. And we always wanted to do something with them at Advantage. They had built a gas plant for us at Modern. And it was actually Brent Allardyce, the president, and Mike talking in the background going, this carbon capture could be something. And so ABC went away and sparked up a team. And if anybody's been around long enough to remember BDR, the B in BDR is the B in ABC. And he's a real technical guru, Rick Bauer. And, I've been hearing of him since 2001 when I first got to Calgary. And so anyway, he went away and formed a little team, and they did some research into carbon capture, post-combustion style, because we've been doing, pre-combustion carbon capture or acid gas removal from produced natural gas for a while. But he did the research on post-combustion, found that the leading experts were at the University of Regina, met with them, found that they had a new solvent that had not been deployed commercially yet, did research on the performance of that solvent, and made up a process which leveraged the performance of that solvent. That came through ABC. Mike, our president, recognized the value and basically came up with the vehicle to commercialize this through a company called Entropy, which is obviously what we're here to talk about, and it's essentially green tech, right? Mostly owned by Advantage, which is kind of weird. Green tech company owned by an oil and gas company, but be that as it may, we're now getting it off the ground, and we've come to this point here.
Excellent. That's a very comprehensive look at your background and a bit of foreshadowing, actually, for Matt. Maybe if you don't mind sharing a bit of your background as well, Matt.
Sure, yeah. I'm born and raised in Calgary. Started off at UC in biological sciences, but at the time had a few other extracurricular distractions. And then once I decided that I needed to finish school, I realized I really wanted to be in physics or geophysics. What drew me really to geophysics was then getting asked to go to some social events, particularly the Doodle Spiel. And after one Doodle Spiel, I kind of knew that this was where I wanted to be. So if any of the guests haven't been to the Doodle Spiel, you got to come. It's a really great time. And then from there on, I got my first job in similar to James in a service company, and then I was interested in being an operator. So I started my career after school at Shell in processing and interpretation, and then went over to Painted Pony to fill in the technical gap that was gone after James had left, and then was there for a few years, and then I guess through my connections with James and the Painted Pony Modern Advantage team, I was able to join Advantage. So and yeah, I've been really fortunate to also be a part of Entropy as it's gone from its infancy to where we are now, which is still I would say in our infancy, but definitely farther along. So
sure. At one point, I do want to get to how you sort of transition from geophysics to now you're investor relations at Entropy.
Yeah, well, I guess that's a good question. I mean, I'm still full-time geophysicist at Advantage, and we're still going really hard at Advantage. Things are very busy, and we're very active Montney producer, primarily natural gas. But on the investor relations side, I think it's more of using your skills as a geophysicist. I mean, we're kind of built to tell stories. We're built to document things on PowerPoint because we can't just show our seismic all the time. We have to tell a story. And I think some of those skills, whether it be telling a story or documenting it in PowerPoint, can be transferred to things like investor relations. And another one of my, I guess, geophysics ideologies is that we need to go outside of geophysics to find different applications for our skills. So for example, learning completions, learning obviously geology, learning how to contribute in drilling and on the economic side. So as we find more ways or learn more about the business, we can find more ways to apply geophysics to help influence specific business decisions.
I can add to that. I mean, Matt's a wonderful geophysicist, but he's also a very well-rounded individual, and he has many skills far beyond geophysics. And although soon he will be instrumental in his geophysics skills, will be instrumental in Entropy's business, that we're not at that stage yet.
Right. Yeah. And we can go into a bit more of that. Well, we can talk about it now. I think right now my contribution to Entropy is early on the IR side, but as the business evolves and as we get more projects, certainly I think I'll then migrate back to a technical role. And I think on that, early on in the scoping phase of a project, obviously we need to understand storage capability. But once you get past scoping and you have a feasible project and you can get it funded, the real work really starts, both on the engineering side and on the subsurface side. So one of the things that we're trying to get more into that we want to be, I guess, technical experts in would be on the modeling side, plume modeling, because we want to be able to test, we want to be able to understand all of our subsurface parameters, our ranges of rock properties, and we want to understand how those ranges will contribute to our container, and to really understand, I guess, the sensitivity that each attribute will have. And then as you get data, as you are monitoring, you get fence posts into your models, and you can further refine your modeling. And so I think subsurface expertise will be really important on the modeling side. And then once projects are underway, the measurement, monitoring, and verification side, MMV, will be a really important role for subsurface, for geoscientists. And I think that's not really well defined yet. I think that's going to be a tailored solution for every project. But certainly we'll be using some actually legacy subsurface methods again, and I think that work really well on the monitoring side. I know UC and Don Lawton and Greg Maidman are doing some really, really cool work testing out different technologies, different diagnostic tools. And I think we'll need to really leverage all of that work and all of that technology into properly measuring and validating our containers, our CCS.
You went through a lot of detail there, and I think that's a good place to take the conversation. But before we get to that point, maybe for everyone who's joined us, you have a presentation, a couple slides, just to go into more detail about sort of the business model, what your goals are of Entropy. Yeah. And while you get that fired up, so yeah, anyone listening, hopefully as we go through the presentation, it'll get the creative juices flowing. Think of some questions that you'd like to ask our guests, and then we can get to those in a few minutes after we're done the presentation.
All right, so you can see my screen now, right?
Yeah, everything looks good.
Okay. So yeah, we have a few slides to share. We'll start off with just talking a bit about Entropy specifically. Sorry, just kind of move my screens around here for a second. There we go. So yeah, I think the main thing that actually sets us apart from other companies in this space is that we're actually a full service CCS company. So right from the capture side all the way to sequestration, and as we've discussed a little bit on the modeling and MMV. There are several competitors in this space, but they either focus on capture or storage. Now we have proprietary innovative technology on the capture side, which we'll go into a bit of detail here soon. But we also have a lot of experience on sequestration side. So we have 10 plus years of pre-combustion sequestration experience. Now specifically, I guess in the CCS space, what we know about CCS is that it can be very expensive. And so the technology that we have is really instrumental in bringing the costs down and making it feasible for emitters to be able to contribute to, I guess, the net zero challenge. Now, on the capture side, what we specialize specifically in is retrofitting existing emitters with our modular carbon capture technology, which it doesn't require plant expansion, it doesn't require a lot of downtime, and we also optimize waste heat in the flue gas to make it cheaper, make it more cost effective. It's a solvent-based carbon capture technique. There are multiple ways that CO2 can be captured. Solvent-based is one of the more common ones, and with that we have access to some high performance solvents that also help reduce our costs. So we'll talk about that in a bit later as well. And another characteristic that sets us apart is the ability to deploy capital. So we're still working on this, but the goal would be to give investors the opportunity to get exposure to rising carbon prices. So we're currently underway in a capital raise for that. Now, going to a bit more detail on the foundation of Entropy, we have, as James alluded to a little bit, we have three very unique specialists in the space. We have Advantage, which brings enterprise strength. We have a long track record already of CO2 sequestration. We have in-house subsurface expertise, focused on rock properties and reservoir mechanics for the extraction of hydrocarbons. But it's similar rock properties and geomechanics for storing CO2. We also own our own natural gas processing facility, which becomes a really great testing ground for trying different technology in the case of working with University of Regina. So as James mentioned, we have Allardyce Bauer Consulting, ABC. They're a leading Canadian, Western Canadian EPCM. They're really a boutique facilities optimization engineering company, but they're experts in process design, modularization, and project management. And then University of Regina has CTRI, which is the Clean Energy Technologies Research Institute. And with them, Dr. Raphael Edom and Dr. PT, some of the most cited authors in the CCS space. We have them as advisors, and they've been working 30 plus years in the space, starting with Weyburn enhanced oil recovery. But they have one of the few facilities in the world that have the ability to actually test and produce solvents. And we're very fortunate Entropy has exclusive access to these high performance solvents. So a bit of a summary of the challenge. Greater than 75% of Canada's emissions are generated from burning carbon-based fossil fuels. And that means it's a post-combustion process. So these flue gases, often in low concentration, 3 to 15%. Now, existing projects that we know of right now are actually difficult to reproduce. They're very large projects, take a long time from FID to on stream, and capitally extremely intensive. Now, what our solution is at Entropy is to leverage existing proven engineering processes and trying to achieve commerciality with the process to make it affordable for more emitters. So the key would be to try to get our costs to around $50 a ton, which we think for our project we're at. And we want to make this a solution for the small and up to large size emitters. So we're pretty proud to talk a bit about, and James will go into more detail on it, but about Advantage's Glacier Gas Plant and phase 1 of our project, which it's fully funded and it's currently under construction. It'll be on stream in April of 2022. And it will be sequestering / abating about 47,000 tons per year just in phase 1. And to talk more about the market, now this is all public data. This comes from Canada's greenhouse gas reporting program. This is 2019 is the latest data that they have. But when you look at all the emitters, so on the left histogram, you look at all the emitters, 96% of the emitters emit less than 100,000 tons or 1 million tons per year. Most are under 100,000 tons. When you look at the existing projects, it's tough to compare the really, really large projects that are greater than 1 million tons per year. Now, the 4% of emitters actually emit 57% of Canada's emissions. However, there isn't a really good solution for all the emitters that are less than 1 million tons. Now, with different industries, you also get a variety of different flue gas compositions. And I think one of the strengths that we have with C-Tree is the ability to test different high performance solvents and really customize them for the type of flue gas that we're going after. So when you look at the top histogram, that's the number of facilities for emitters in different industries. And we really think that our technology is industry agnostic. It works really well as long as you have a flue stack. However, the full scope of costs includes capture, transport, and storage. And the transport can be pretty expensive for some of the industrial facilities that aren't near high performing sequestration zones. And that's what makes oil and gas a bit unique. So I'll show this next slide. This shows all of the saline aquifers in North America, along with all the emitters. And what's made the Western Canadian Sedimentary Basin a prolific source for hydrocarbons also makes it a prolific destination for permanent CO2 storage. So that makes oil and gas facilities specifically really good candidates because transport can be really low cost. And we think that right now the focus is deep saline aquifers. However, we think depleted reservoirs show great potential as well. And from a regulatory perspective, we think we'll get there for being able to store CO2 in depleted reservoirs. And when you combine all of those reservoirs plus saline aquifers, really the potential for storage in Alberta specifically, but in the WCSB is really phenomenal. James, you want to take next couple slides?
Sure thing, thanks. So essentially, this is a kind of a, obviously simplified view of what we're doing here, but you start on the left there and you have an exhaust stream that's going to atmosphere. You don't want to do that, so you redirect it into your process and essentially bring it into contact with a solvent that preferentially binds to the CO2 molecule, and it takes it out of the flue gas, cleans the flue gas that you then release. Now you have the solvent, which is rich with CO2, that you bring it over to a regeneration module, and there you essentially boil the CO2 out of it. And that gives you regenerated solvent that can go back to scrub some more CO2. It's a continuous process from that standpoint. And you get essentially a pure CO2 stream off the back end that you then have to do something with. And, Matt just went over the sequestration element, which we believe at this moment is the most economic. But later on, hopefully we'll have some uses for it, and maybe we can, make that a thing later on. There are certainly pilots going on, but for the most part right now, with the amounts that we're talking about, storage underground is probably the best bet going forward. Okay, this is specific to the Glacier project. And first of all, the Glacier gas plant is an ideal spot, really, to put the first project. It's already one of the biggest in the province. It's already one of the most efficient gas plants in the province in terms of emissions per MCF produced. And so we're attacking this in 2 phases. The first phase, as Matt said, is fully funded, and it'll be on stream here in Q2 2022. The abatement there that he mentioned is both capture, but we're also kind of pre-building a bunch of waste heat recovery. So what you can do is take the heat right out of the exhaust. It comes off obviously quite hot, and you can recycle that heat into your process in order to save cost. So there's quite a bit of that in phase 1 that we're pre-building for phase 2. And then we're also doing the scrubbing, basically one Caterpillar 3616, which is a large, natural gas driver for natural gas compressor. And that's where we're getting the exhaust. And then in phase 2, we'll basically round that out to the entire plant. So we're capturing CO2 out of the exhaust from every emitter on that site that's continuously emitting CO2. This kind of gives you a bit of an idea how we fit this in. So the gray buildings are the emitter. So there are 2 emitters there, and they're both representative of natural gas compressors. Now the smaller gray building to the left, really that's just a cooler, and the real business is done on the larger building on the right. You can see where the arrow points to waste heat recovery. That's essentially just the exhaust muffler. So all of them have that, but instead of just going up the muffler or through the muffler here, we redirect into a waste heat recovery unit. And you can see the pipe moving along the bottom down there towards the left. So it goes through that waste heat recovery unit. We extract heat, and you both need the heat for your process, but you also need to cool the gas because the absorption is not done at temperatures like what's coming off of the exhaust of the driver. So you're killing 2 birds with 1 stone, and that speaks to the efficiencies. So then it moves along. It gets pushed into that large yellow tower there, or gold colored tower, the solvent contactor that we say. That's where the CO2 is scrubbed out of the flue gas. The flue gas, now cleaned, is then released. And we're showing the conditioning skid, which essentially takes that rich solvent now and sends it off to a module that's not being shown here, which is the regeneration module that where we extract the CO2 out of the solvent. And again, from there, we send it off to sequestration. That requires compression. So we're adding another compressor here that's not selling gas. It's actually compressing the pure CO2 for sequestration, but we have the ability to put the scrubbing modules on that one as well. So everything gets cleaned before it hits the atmosphere.
So I'll just stop sharing now and open the table up.
So I'd like to see if we have any questions. Jeff, has anyone submitted anything?
Yeah, we have a question from Thalia, and this one's for Matt. Even with your multifaceted skill set that made your transition from technical to investor relations or non-technical work seamless, what would you say has been your biggest challenge in achieving that?
Well, I think it's definitely out of my comfort zone. A lot of on the business side and learning, I guess, learning what the important things that executive types or investors would be looking for. And so I think just being a sponge and constantly listening and trying to learn about the business is just something I'm interested in anyways. But I think that's definitely the biggest challenge to overcome, and that it's not technical. It's not something I've ever really done. So yeah, I mean, there's always tons of iterations in a slide deck, and it's never perfect. So.
Maybe I'll ask a follow-up to that. So how did you decide that this is something that you wanted to do? Did someone ask you to do it and you just can't say no, sort of thing, or?
Well, I guess maybe a bit of a combination of that. I mean, Advantage, we're a really lean company to begin. We produce about 50,000 BOE per day, 90% of which is natural gas, but we have less than 40 full-time employees in Calgary. So we're a really lean shop. And when it came to Entropy, early days as a startup, you're not able to staff up Entropy yet. So it's basically, we operate it with all hands on deck all the time, and whoever contributes.
That's a really good answer, and I think it puts into perspective sort of when you work for a smaller company, everyone's sort of the Swiss Army knife, right? If you have a skill that you think might outshine a coworker for a certain aspect, that's something you would just raise your hand for. So yeah, I'm glad you addressed that. Jeff, how are the lines looking?
Yeah, we got a couple trickling in. Here we have a question for Mike in regards to what is the sequestration zone, and maybe you can discuss some of the earth science inputs that go into it. I know before you were talking about modeling, and maybe a question to ask is how different is it from the traditional, I guess, conventional, understanding of oil and gas reservoir?
Yeah, so I guess our current acid gas disposal scheme is focused on sequestering acid gas into the Beloit or the Taylor Flat. As our phase one comes on stream, we'll also be sequestering into the Taylor Flat. We're also preparing to sequester into some other zones uphole as well. So as we grow, we know that we're going to have to probably expand our sequestration zones. We're looking for high porosity, high permeability. We're looking for obviously containment is the most critical factor, and multiple levels of containment as well, not just one level, multiple levels. From a subsurface perspective, we're looking for structure. We're looking for potential pathways that might, I guess, reduce the quality of your seal. So yeah, there's a lot that goes into it.
Awesome. Did you have any other follow-ups or any comments as well, James?
Yeah, well, one thing I can say about sequestration is that is on the minds of most people. So this turns out to be one of the largest concerns that people have. And it's also, other than in Alberta, the regulation around sequestration is actually quite mature. But in other jurisdictions, it's not the case. And they're really trying to figure out how they can develop a proper set of regulations to be able to address this, because people, I think, intuitively know that carbon capture is coming. It's a necessary step in our energy transition, but it's not every place that has it all, as sorted out as we do here in Alberta, and we're very lucky to have that.
Awesome. Yeah, thanks for your comments. Jeff, it looks like we have a couple more.
Yeah, maybe this one could be for James to answer. We have a question from Miles. Flue gases typically contain components that cause higher rates of solvent degradation, oxygen, carbon monoxide, etc. How do you plan on managing solvent degradation and heat stable salts?
Yeah, well, that's a very good question, and it's a very real concern. It's one of the main concerns in all of this. And so essentially what we have here is, again, as Matt pointed out, we have access to the University of Regina. And they've been doing post-combustion carbon capture chemistry for 30 years. So 30 years ago, the government of Saskatchewan realized that they needed CO2 for their Weyburn oil field, which was the largest oil field in the province. And it was, requiring tertiary at the time. So they needed a source of CO2, and they fired up this research facility at the University of Regina. Now, they subsequently got another source for that CO2, and we all know the Weyburn field has been happily flooding with a US source for a while. But that research continued. And really, it continued in spite of the fact that not many people were interested. But they are the world leaders in the chemistry. So a lot of the improvement in terms of the degradation has come specifically from the chemistry of the solvents that we're dealing with here. So they're much more stable than typical amines. And that's very important. They're also more efficient, and that's, of course, good, but it's also a double whammy good because their efficiency allows us to essentially do that reboiling, where we remove the CO2 from the rich solvent. We can do that at a lower temperature, which helps degradation, helps avoid it. And so those are two main aspects. Inevitably, we are going to see some degradation. There's no way that we got a perpetual motion machine here. But for that, we have proper reclaimers. So these are specific pieces of equipment that do some ion exchange with the solvents and scrub out the degraded aspects so that we can then just put a little new makeup in and continue the process, continually.
Well, a good question got a good answer. So thanks for that. There looks like the questions are coming in hot and fast. I think I have plenty of questions, but I think we should get to those coming from the audience. Jeff, what do we have next?
Yeah, we have Chris here with a question, and this could be for Matt or James. And what have been the challenges and successes for funding future projects from Entropy's and your prospects' point of view?
Well, I don't know if we can fully answer that one quite yet. I know, and as I think just from the news this week, you'll know that CCS is going to be a big part of the future for us. And with that, there's going to be a lot of funding and grants available. We've certainly applied for some grants on the front end engineering side, and I hope that more of that becomes available to really be a catalyst to developing our industry. We feel like our costs are, we can get $50 a ton on our project, but like anything, as you develop more projects, we think we can even improve that. And at some point, you'd hope that it gets to be self-sustaining, but we need that push right now to get there.
And James, you'd echo those?
Yeah, one of the main challenges we've seen is that, we believe we have the best process in the world here, essentially. We have the experts and we have the process down, but it hasn't been deployed commercially yet. And there are others out there claiming that they have the best process. And so to the eye of the investor who's going to put money into these projects, he doesn't know who to believe to begin with. And so they're very reluctant to sign on with any one given party. Everyone knows it's coming, but where to put your money is a question. And so that's been a challenge for us to basically differentiate ourselves from all the other, in some cases, valid competitors, in other cases, snake oil salesmen.
So would you say you guys are sort of in a show me phase? You'll phase one will come online, you'll have the results from that, and then you'll be able to prove to future investors or partners that this is indeed doable at the price that you say it is?
That's correct. We're definitely in a show me phase, and as Matt said, we are in a position, or getting ourselves into a position, where we can deploy the capital, because what we have found is even the people who need carbon capture for themselves, so you have a large emitter facing a huge liability in terms of carbon tax, they know they have to clean up their act, but they're not willing to spend their own money on it. So in order to accelerate the process, we're planning on coming in and deploying our own capital to get that project up and running. Because as we all know, the time's really wasting here.
Yeah, definitely.
And just add to that, we want to provide a full turnkey solution. So right from the capture side to the sequestration side. That's really what sets us apart.
Well, it's definitely a great concept, and I think most people look at carbon sequestration as an EOR tool and not a storage tool, and so you guys are definitely looking at it from a different angle than most people right now. So just looking at the time, we have about 15 to 20 minutes left, so be sure if you have any questions, get them in the queue. Jeff, do we have anything to follow up with?
Yeah, we have one question. Is the CO2 stream pure enough and volumetrically large enough to be used for tertiary recovery?
Maybe that's a James question. I'll direct that to you.
Absolutely. It absolutely is. And the only reason we're really focused on, on sequestration at this moment is just that we're focused on getting it out of the atmosphere. And right now, the most, the quickest way to get this going is just get it in the ground and leave it there. But as other things develop later on, we're certainly willing to go to all forms of utilization, including EOR, and it's certainly pure enough, and we have enough volume, or hopefully will soon, to be able to supply.
Yeah, I guess maybe you guys can comment. So you guys talked about Weyburn, huge project that's been going on for decades. The Alberta Carbon Trunk Line, which you guys are probably familiar with, which is this taking gases from Nutrien and Sturgeon Refinery just north of Edmonton, and they're actually re-injecting that into the Redwater Reservoir, which is, pardon?
The Clyde Field?
Yeah, exactly. So yeah, and that's, in terms of, other than that, there aren't any major projects of that scale. In terms of EOR, if you guys get involved with that, would that be, you would have the hardware, and then the company that you implement before would be responsible for doing all of that research?
I guess the one missing, just before we go on to that, is we have Quest, 1.2 million tons per year off of the Scotford refiner, upgrading bitumen to oil, but that's like a private project. But I guess we're focused right now on pure sequestration primarily because we're also focused on carbon credits. And right now there isn't an established credit program in Canada, at least, on EOR. Now, if we were going to voluntary credits, then maybe that's a whole different conversation that we're just really learning about as well. But for our clients and investors, we're focusing on right now on pure sequestration, although the components would totally be compatible with any type of EOR as well.
Yeah, I guess, make sure you guys make sure it works, I guess, right? Before you look too far down the road. On one of your maps, you showed pretty much anywhere in Alberta, there's reservoirs in which you could store carbon dioxide. Why don't you think more people are looking at this as a way to offset CO2 production? You look at the oil sands, like as probably some of the largest emitters in the WCSB, they would benefit greatly from this. Why are you guys what do you guys think you're doing this as opposed to some of the larger companies?
Well, I think it's just such a new technology, or a new space that I think a lot of people are wanting to get into it, but there just right now isn't the technology to do it at scale for small to mid-size emitters, at least for something that's economic. And so as the carbon price evolves and as the technology evolves, I think more emitters will have the ability to contribute to reducing emissions, and I think it's going to be a huge part of the future. So that's definitely why we're in the space.
Yeah, go ahead, James.
It's definitely been a problem where we didn't recognize the value. So it's only in the last few years that we have things like carbon tax, things like investment credits that they have in the States, and that we're already talking about in Canada. You know, the price of carbon essentially has been too low for this type of technology to get off the ground. And that's really what's changing. And that's what the professors talk about all the time. They've been doing this for 30 years. Nobody cares. That's what they say. And now finally somebody cares.
You actually, you sort of talked about my next question. Yeah, what is the pricing outlook looking for you guys? Because, you know, you have modest returns sort of at that $40 to $50 per ton of carbon dioxide for storage. But, you know, just hearing what's coming down from the government, you know, I'm hearing upwards of $170 by 2030. You know, do you think that'll make this industry a bit more competitive?
Yeah, and I think that's exactly what will happen if we reach those if and when we reach those carbon prices, is that this industry will become self-sustaining and not need government subsidies to continue and to grow. And I mean, it's not going to happen if it costs money for people, for emitters, but if they're incentivized to do it, then they will do it. And key that we do it the right way.
Yeah, do you have any comments to add to that, James?
No, I think that's nicely said.
Sure. Maybe back to you, Matt. So you're sort of in the investor relations space. You know, what are you hearing on the street? You know, are you going on road shows, talking about what you guys are doing? What do you guys hear from sort of the investors? Any insight into how the street's looking at this?
Myself right now, I don't know if it's just because of COVID or just because we're early days, probably a bit of both, but I haven't been going on the streets. But what we do know is that there's a ton of momentum and a ton of interest in the space. We actually currently only have one dedicated full-time entry person, and he's in business development, and he's in meetings all day, every day. And we constantly have more people at least interested in understanding the technology and looking for scoping. And as James mentioned, I think once we can prove our costs, once Glacier is underway, and even though we're confident in our components, once we put that all together, it's gonna get even busier. So yeah, there's a ton of interest, not only from producers, and not only just oil and gas, but all sorts of industries. Yeah, you name it. I think we're getting a lot of interest, and not just Canada as well.
Awesome. Yeah, thanks for answering that. Jeff, how are the lines looking for questions?
Yeah, so we have a question here from Jeremy. Look, it sounds like Matt had referenced U of C and Dr. Lawton, and Jeremy was curious if any of their learnings or tech for monitoring is being applied now, or more so down the road.
Yeah, that'll be definitely more down the road for us. We're right now in a learning phase of trying to understand all of the potential diagnostic tools that are out there. Obviously the costs of them and what they can help us with. Right now, with our current pre-combustion sequestration scheme, we abide by the AER's acid gas disposal regulations, and as those regulations evolve is when our projects will evolve. Now, I think for us, the most economic third-party projects are the ones that might have existing disposal like Glacier does in place already. But once we get to projects that we need to actually drill disposal wells and leverage monitoring wells, that's when we'll really have to collaborate more with Dr. Lawton and Greg Meadman.
Yeah, it's interesting, just the amount of sight that carbon sequestration is getting lately. Just in my email the last couple of weeks, so Don Lawton had a CSEG luncheon today. There's the Gallagher colloquial series where they're talking about CO2 for uses for alternate things. It just seems really top of mind for most people, which I found quite interesting. Yeah, Jeff, how are you looking for questions?
Yeah, we have just a quick question here about Matt's office. Is that a ant farm behind you located by the window, or is that some kind of structural geological model?
It's like you can turn it over and then the sand deposits, so you can kind of play with it. I have a nice mountain built in there, and I've left it for a while, but it's just art.
Okay, typical geoscience, geoscientist, thing. Oh, so we have another question here from Sherry. Great leadership and actions for both of you. Would you share how you personally became convinced that a climate change mindset is required for the future? Was there some sort of data or story that had a particularly effect on you? And I guess that goes for James and Matt. Maybe you guys can share a little anecdote or story where, you developed this mindset.
Yeah, well, I can start. First and foremost, as I said, I'm from Ontario, and my family is still from Ontario. And they just think we're terrible out here with all our emissions. And I have 3 daughters, and they all live on the West Coast, so it's even worse out there. So I can't even go visit family unless I'm doing something to clean up my act, essentially. But aside from that, I think there's enough data that tells us, we're going to have to do this. And so I could say that for methane reduction. But to be honest, in terms of this carbon capture venture, I was just in the right place at the right time.
Yeah, and I guess to comment on that, it's a really tough subject. I mean, we know that as geoscientists, the climate has changed always, but we also know that the anthropogenic contribution to atmospheric CO2 is considerable. And so if we can do something to minimize that, great. And I think we also have to look at the societal and the political environment that we're in. And I think for us to continue as an industry, we need to do our part.
Sure, that's a great response. We just have a few more minutes, and I don't think we have any more questions left. Looks like we hit everything. Maybe one to take us out. If we were to have the same sort of interview in 5 years, sort of what is the roadmap looking like? Where do you guys want to be? Do you guys have any goals that you guys have set out for yourselves? And maybe I'll let James start off with this one.
I certainly hope that we 2 things. One, Entropy is the leading provider of carbon capture to the world, really. And 2, that is resulting in actual decarbonization in a material way.
And Matt, I imagine you express similar
goals. Yeah, similarly, I hope to provide a solution for all small and mid-scale emitters to be able to contribute to reducing emissions and leverage against carbon pricing. And I think just to change, I think the rhetoric of our industry.
Awesome. So it looks like we had one question squeak in. Do you want to get to the last one for the day, Jeff?
You bet. So how will the sites be monitored and managed? As with anything, assuming leakage into overlying sources of drinking water cannot be ruled out. Probably this is a question you guys get a lot. So how well are they contained? How do you make sure that there's limited risk?
Yeah, that's a super good question. I think right from the scoping phase, we're looking for sequestration zones that are deeper than 1,000 meters. So significantly deeper than drinking water, where drinking water would be. Now, for each project, I think there's going to be a customized MMV solution. I think regional structure, regional faulting, induced seismicity, these kind of things will go into understanding some of the risks up front. And then I think 3D seismic is going to be important for understanding the container and trying to really map out regional structures and faults. But I think on the geology side, first, we need multiple seals. We need primary seals, secondary seals, ultimate seals, which we often have. in Alberta. And then we need to find ways to I guess, monitor without disturbing the integrity of the seal. So we know that there's already some great technology in that field. And then I guess traditionally on pressure monitoring, which we do, which with wellbore integrity, which we're really on top of, which James specifically is really on top of. That's going to be key in making sure that we can maintain pressures, and then continually modeling, point modeling, and calibrating and dynamically changing and evolving our models will help us really understand where plumes are migrating and understanding our containers.
And I think it's important to keep in mind that the regulation we are dealing with here has been developed primarily for H2S, which is an even more problematic gas, right? So we've been doing this for decades, and if H2S comes to surface, people die. And not only do you have to prevent it from coming to surface, but you can't even prevent it from influencing offset producing zones, which are very much closer. So the set of regulations we're dealing with are actually very good. And that's what we're using going forward. And if that's the Amber that I know, she's going to be an integral part as our chief inspector to make sure we're doing this the right way.
Oh, is that a bit of an insider question, a softball to something you guys already have prepared?
I just noticed the name.
Awesome. Well, I think that's a good place to wrap it up. I just want to give a tremendous thanks. I hope on behalf of everyone who attended today, a huge shout out to James and Matt for taking the time to speak with us today. For those of you in attendance, we hope you guys have enjoyed this discussion. Please feel free to follow us on LinkedIn at our CSEG Mentorship page. We plan on having a few more AMA sessions throughout the year. The next one should be scheduled for early January, so keep an eye out for that. And then also feel free to hop onto our YouTube page. We have some AMA sessions from last year. We hope to get this one up there again for everyone to view, and for those who missed it, they can see it there. So yeah, once again, thanks again for helping us today and teaching us more about CCUS. And with that, I'll sign off.